how to predict the products of a synthesis reaction. First of all, we have to be able to identify when we're actually dealing with a synthesis reaction. If you remember from what we talked about before, a synthesis reaction can usually be identified by the fact that it makes one single product. But what if you're not given the product? The other way to identify a synthesis reaction will be any reaction in which your reactants are two individual elements. Anytime we see a reaction that begins with two elements on the reactant side, then we can be assured that this is going to be a synthesis reaction. Now, the neat thing here is that we can always predict what the products of a synthesis reaction are going to be because they're always going to follow a similar pattern. Your reactants are always going to be two elements. The product, single product, is always going to be ionically bonded. Meaning, what we're going to have to do to correctly write the formula for our product is recognize the charges of the ions that are going to be going together to make it in the first place. So let's look at a quick example. If I were to take a reaction involving sodium, written like so, and fluorine, written like so. If you remember, fluorine is a diatomic element. It gets the 2 subscript here, and the sodium is not a diatomic element, so it doesn't. So if we wanted to figure out what the product of this reaction is, what we would first need to do is recognize the charges that these particular elements would make. So to that, we can go to the periodic table. If we remember from our formula writing, sodium being in group 1 is always going to have a 1+ charge, and fluorine being over here as a halogen is always going to have a 1- charge. So if we take sodium with a 1+ and fluorine with a 1- and crisscross those charges, we get our single product to be sodium fluoride, NaF. Now, this does not give us a reaction that is balanced, but that is why we learned how to balance first. What's way more important than just getting a product that automatically balances is that we get a product that is correct. All of our ionically bonded products, or all of our products, are going to be based on ionic bonding rules. And it's always purely going to be a matter of the ions that are going together. In this case, sodium and fluorine, each with a 1+ and 1- respectively here, crisscross those charges to give us sodium fluoride. This also highlights the difference between what I mean in a previous video talking about how when to write the 2 subscript for diatomic elements. Here, fluorine is by itself, so it gets the 2. Here, fluorine is bonded, so it doesn't. If we wanted to balance this reaction, we could put a 2 here for the sodium fluoride. That would fix our fluorines. We would need a 2 here for the sodium, and then this 1 here for the fluorine. Let's take a look at another quick example. Let's say I took something like some aluminum and reacted it with some chlorine. Oops. Again, we can recognize that this is a synthesis reaction because the reactants are 2 individual elements. So to predict the product, we consider that the charge of aluminum is a 3+, according to what my periodic table says, and that the chlorine is a 1-. So to get that formula, again, we crisscross the charges, and that gives us AlCl3 as our product. Synthesis reactions are always going to follow this pattern where we're taking the charges of the ions that are going in, crisscrossing those charges to get our singular product. And then we balance from there. In this case, to balance, we would need to first fix our chlorines, which would require a 2 here and a 3 here, followed by a 2 here for the aluminum. Every single synthesis reaction can be predicted in this way. Look at the ions, or the charges of the ions that are going in, and use those charges to write your single product.